Continuing on in section 3.5, when working with sets, we call the largest set we are using the universal set or a universe. The complement of a set is the set of all elements in the universal set that are not in the set. We denote the complement of A as A prime here, A with a little tick mark. Look at the Venn diagram on page 196. Here I have a little picture of it as well, but the picture in the book is way better. Both A and its complement are subsets of U. So U is my universal set. Okay, U is this entire rectangle. A is one of my sets, and A prime, or its complement, is everything else in the universe that's not in A. So I didn't color that in great because my highlighter's big. But both A and A prime are subsets of U, and together they make the entire universal set. Okay, so if we have a set that's our universe, like the numbers 1 through 10, A could be numbers that are even. Its complement would be then numbers that are odd, the numbers that aren't even. And together, that gives us all the numbers 1 through 10. Okay, so A and its complement, and we use this little guy to show complement, are subsets of our universal set. So here in example 4, we're going to find the complement of a set. On page 196 here, they show us the pieces that are needed for a chess game. The pieces in our universal set, so all the pieces are king, queen, bishop, knight, rook, and pawn. They also show us how the pieces move there. So our set A is going to be the chess pieces that move side to side. We want to know what is the complement of A. So we want A prime equals all the pieces then that don't move side to side. So the king can move exactly one spot in each direction. Okay, exactly one spot in any direction. So the king can move side to side. That's an A. The queen can move any number of spots in any direction. So that can move side to side. That's an A. The bishop moves diagonally. So that is not a piece that moves side to side, which means it's in our complement. The knight moves in L-shaped pattern, 2 one direction, 1 the other, which means it does not move side to side. The rook moves just left and right or just up and down, so that can move side to side. And the pawn only moves forward, either 1 space or 2, depending on which turn it is. Can only move 1, the first time it can move 2. So our set of pieces that move side to side here are king, queen, rook. Everything else that doesn't move side to side, bishop, knight, and pawn, make my complement. And if we put those two together, that gives us our entire set, our universal set. So here, our universal set is months of the year. A are months with exactly 31 days, and we want to know what is the complement. So I'm going to actually list out my months of the year. January, February, March, April, May. I'm abbreviating some of these for space. So there are my months of the year: January, February, March, April, May, June, July, August, September, October, November, December. We want the months with exactly 31 days to be in A. So January has 31 days, March has 31 days, May has 31 days, July, August, October, and December have exactly 31 days. Which means our complement, A prime here, are the months that don't have exactly 31 days. They're everything that's left over. So February, April, June, September, and November. 30 days has September, April, June, and November. All the rest have 31 except for February, which has 28, on leap year 29. Or you can use a little knuckles trick. We talked about that in class. The highs are 31, the valleys are lower than that, either 28 or 30. But either way, so A, again, the months with exactly 31 days are January, March, May, July, August, October, and December. So its complement is everything else: February, April, June, September, and November. Because if we combined A and its complement, that would give us our entire universal set, all the months of the year. Quick recap here. Sets are the basis of mathematical language. Sets are written in different ways, including roster form and set builder notation. The elements not in a given set are the complement of a set, and smaller sets of elements can be formed from a larger set. And that's all I have here for section 3.5.